Right, in geometry, we're moving on to section 4.4 out of the chapter that we've been in, and this is an introduction to it. And in your notes, label your notes lesson 4.4, and the topic is called isosceles triangle theorems. And so what we're dealing with right now, if you remember, let's just review this just very quickly here. So far in this chapter, we've talked about what's meant by congruent triangles. Remember, corresponding parts of congruent triangles are congruent. We've talked about ways to prove triangles congruent. And we've had SAS, we've had ASA, and we've had 3 sides being congruent to 3 sides. And in section 4.3, so this was section 4.1, and then we had section 4.2, and in section 4.3, we use congruent triangles. And in other words, corresponding parts of congruent triangles are congruent. So now we're to section 4.4, where we're getting a little bit more detailed on using triangles, and namely isosceles triangles. What I have here is a proof that as a class we're going to do here eventually. I'm going to skip over that right now. In your notes, let's write down this screen here, and this is the parts of an isosceles triangle. So why don't you pause this and copy that down. Now what I have here, an isosceles triangle, as most of you remember, an isosceles triangle is where you have 2 sides being congruent to one another. Now there's also other parts to an isosceles triangle, and this is probably going to be the very new part for you. First of all, we have, and I'm going to highlight this, okay, we've got the 2 sides that are congruent. Okay, those are called the legs. So the 2 sides that are congruent to one another are called the legs of the triangle. Now, the side that's not a leg is called the base. And if you look at this closely here, the 2 angles associated with the base are the base, what we call the base angles. And I have arrows going to those. So in other words, the 2 angles that are associated with the base are called the base angles. Now the third angle that is involved in a triangle is called the vertex angle. So in other words, notice that the vertex angle is made up of the 2 legs. So we have the vertex angle and we have the 2 base angles. So I just really want you to be familiar with the vocab on this. Vertex angle, leg, base, and base angles. Now moving on here, I want you to pause this again and copy down what's called the isosceles triangle theorem. All right, in the isosceles triangle theorem, it states if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. Now you've had this before in algebra a number of times. Maybe you've understood it real well, maybe you haven't. So the 2 sides, if 2 sides of a triangle are congruent, and I can see that this is marked, so these 2 sides are congruent. The angles opposite those sides. So in other words, if I take a look at this side that I'm highlighting right now or marking over, the angle opposite is right here. And then this side, what's the angle opposite that? Right here. So if 2 sides are equal, the opposite angles are equal. And notice that I put the same mark through these to show that they're going to be equal. So if 2 sides of a triangle are equal, the angles opposite those are equal. Just to emphasize it a little bit more, how about if I have a triangle setting like this, and these are the 2 equal sides. Okay, what are the angles opposite them? Well, the 2 angles opposite these sides, well, this one, the angle opposite this one is here, and the angle opposite this one is here. So those would be the 2 opposite angles that are equal to one another. Now, what we're going to do here is prove this theorem. So I want you to pause this and write down your given, prove, diagram, and the 2 columns. All right, let's prove the isosceles triangle theorem. And this is going to probably be, if I remember right, I'd have to look back on my notes, the first proof in this chapter that you probably have in your notes. All right, so let's start this here. Given AB is congruent to AC. So I'm going to mark that down in my diagram, and I'm going to write it. So AB is congruent to AC, and that's given. Okay, statement 2. Now the whole idea here is I'm trying to get angle B congruent to angle C. Where can I go? Well, one thing that we could do here is I could make what we call an auxiliary line. So I'm going to drop a line from angle A. I'm going to make a dotted line, and you need to do the same thing on your diagram to the midpoint of that. So in other words, what I'm going to do here is I'm going to draw a line to the midpoint of BC. Now, I'm just trying to think here which direction I want to go on this. Yep, okay, so the reason on this, so first of all, I'm going to, let's say, draw AD. And I'm going to put a point D right there. And the reason on that is between any two points, there is a line or a segment at the midpoint. Okay? Now, you'll see the reason why I did that here in a little bit. Okay, statement 3. Now, what I'm going to do here is I'm going to deal with this triangle now that I've created in the green, and this triangle in the yellow. And what I'm going to try to do is I'm going to try to get those two triangles congruent to one another, because notice that B in this angle and C in this angle are corresponding angles. So I'm going to try to get those two triangles congruent to one another. I already have one side. Well, I could say that AD is congruent to AD, right? We've had this a number of times, reflexive property. And finally, number 4, so now I have another side. Now remember, I drew that red dotted line to the midpoint, so that's saying then that BD is congruent to DC. So BD is congruent to DC. Reason, definition of the midpoint. Now, in statement 5, can I get those two triangles congruent to one another? And I can. So I could say that triangle ADB is congruent to triangle ADC. And the reason is 3 sides in one triangle congruent to 3 sides of another triangle. Now, I've got the two triangles congruent to one another. Now I can say that angle B is congruent to angle C. And the reason? Corresponding parts of congruent triangles are congruent. So we've proven the isosceles triangle theorem. Okay, let's take a look at, and actually I'm going to wait on this here because I want to go through this in class. Today I just want you mainly introducing this. All right, I want you to pause this and I want you to write down corollary 1 and corollary 2. All right, corollary 1, it says an equilateral triangle. So equilateral meaning that all 3 sides are equal, right? Is also equiangular. Equiangular meaning all 3 angles are equal. Well, why is that so? Let's see. What's the angle opposite this side? Here. What's the angle opposite this side? Here. So we know those are equal, right? I'll kind of watch as I go through this. How about if I'm dealing with these 2 sides? What angle is opposite this one? This one. What angle is opposite this one? This one. So you can kind of go around in that same cycle, and you can see that if you have 3 equal sides, well, you're also going to have 3 equal angles. All right, corollary 2. An equilateral triangle has to have 3 60-degree angles. Well, corollary 2 carries on from corollary 1. Because if you have 3 equal angles, and knowing that they have to add up to 180, well, you know what? Each one's got to be 60 then. And that's how corollary 2 follows. Okay, pause this and write down corollary 3. All right, in corollary 3, it says the bisector of the vertex angle. Now, first of all, let's identify my vertex angle. This is a base angle, right? And this is a base angle. So, this is my vertex angle up here. It says the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. So, in other words, if I draw a line and it bisects the vertex angle, and I draw it to the midpoint, and it's perpendicular, it has to hit that base side at its midpoint. So the bisector of a vertex angle of an isosceles triangle has to be perpendicular to the base at its midpoint. So if I drop that line and it hits the midpoint and it's bisecting this vertex angle, it has to be perpendicular to that base side. And this we'll cover a little bit more in depth as we go along. Okay, if I remember right, I believe this is the last one. I want you to pause this and copy down Theorem 4.2. All right, in Theorem 4.2 it says if two angles of a triangle are congruent, well, you know what? The opposite sides. So what side's opposite this angle? Here. What side's opposite this angle? Here. So really, this is the converse of the isosceles triangle theorem. So if two angles are equal, the opposite sides are equal. Lied, here's one more corollary. Okay, in this corollary, pause this, write it down. An equilateral triangle is also equilateral. And this kind of carries on from the same effect as what we said before. Let's see, what side is opposite this angle? Here. What side is opposite this angle? Right? So this corollary actually carries on from Theorem 4.2. If two angles are equal, opposite sides are equal. Well, how about if I'm talking about this angle and this angle? What are the opposite sides? Well, here and here. So you can kind of see that this is kind of carrying on from the theorems and corollaries that we had before. And we'll talk about these in class here to finish introducing this section. So the topic of section 4.4 was called isosceles triangle theorems, along with some corollaries.